Hello, let's continue our time series using R video series. In this video, I will talk about how to perform the Conditional Granger Causality Test. First, let me just talk a few key points about the Conditional Granger Causality Test. It is about a 3-time series X, Y, and Z. Okay, so it tests if X lags predict Y after controlling for Z lags. Okay, so the null hypothesis H0 is X lags at no predictive value beyond Y and Z lags. So it uses multivariate VAR, which is an F-test, compares restricted versus full models, and eliminates spurious causality from confounders. And in R, it uses the causality function from the vars package. And do keep in mind about the limitation. It is a predictive causality, not structural causality. All right? Okay, so now let me show you how to do this in R. So we need one package called LMS test. Load that in. And also we need the vars, the VARS library. You can simply install it by install.packages /vars. Okay. Load that in and set random seed, which simulate 3-time series t equal to 200 observations and n equal to 3. We generate 3 stationary R1 processes with conditional causality structure. First is x1 go to y given x2. So y depends on lagged x1 even after controlling for lagged x2. So let's create an epsilon matrix. X1, X2, Y, placeholders for the time series data. And then we just initialize the first values for X1, X2, and Y. And then we generate the time series with conditional Granger causality built in this data. So for T in 2 to T, capital letter T, we use this X1 is actually assigned as 0.5 times 1T minus 1 plus epsilon T1, and x2 T is 0.4 times x2 T minus 1 plus epsilon T of second column T2. And then the Y depends on both its lags and x1 lags, conditional causality. x1 causes Y given x2. Okay, so this is the YT is 0.6 times YT minus 1 plus 0.3 times x1 T minus 1 plus 0.2 times x2 T minus 1 plus epsilon T3. Okay, and put everything into a data frame, and this is what it looked like. We got the time point, and we got x1, x2, and y. All right, first we need to convert to time series objects in order to call those packages for time series data, like vars. So TS x1 is TS, just x1 start from 1 frequency equal to 1, TS x2, TS y. Let's do a little bit visualization. This is what it look like, x1, x2, and y. And then first let's do unconditional Granger test, causality test without conditioning. Okay, so this is a conditional Granger test. Print x1 does not cause a Granger cause y. Just using Granger test, y tiered x1 order equal to 2, print it. Okay, the p-value is rather small here, less than 0.05. Then another one is x2 does not Granger cause y. And this p-value is also very small. So unconditionally, they both x1, both x2 both Granger cause y. Okay, but then we do conditional Granger causality, assuming multivariate VAR. Okay, so this is a multivariate var, and then we create the multivariate time series matrix, which is C bind Y x1 x2, and give column names, turn them into a time series object, and then we use VAR2 model for all 3 series. So the syntax is VAR Z underscore TS p equal to 2 type equal to constant. Okay. And now we can test, does x1 Granger cos y conditional on x2? So the h0 is lags of x1 do not help predict y after controlling for lags of y and x2. So let's do that. And then here we use the causality function. So causality of var underscore model cos equal to x1, double quote around x1, and at Granger. Okay. Then we can print it out. And the p-value now is 0.06, which is above 0.05. Okay. So we can also test, does x2 Granger cos y conditional x1? Okay. And we can use causality var model cos equal to double quotes x2 at Granger, and then print it out. Now the p-value is still small. Okay. So this, we can also test reverse direction, which is y does not Granger cos x1 given x2. Okay. So similarly, now we have causality var model cos equal to y at Granger. And this gives a very large p-value. Okay. So how do we interpret this? The interpretation is, first is unconditionally both x1 Granger cos y, x2 Granger cos y significantly, that is p less than 0.05. And conditional x1 Granger cos y significantly, because its p-value is less than 0.05, x does not cause Granger cos y significantly because p-value is greater than 0.05. So this demonstrates x1 cos y conditionally on x2. Okay. And we can do some summary statistics. The true data generating process, let's just print it out, and which is x1 Granger causes y even after controlling on x2. Okay. So this example shows you when we have 3 time series, then the Granger causality can get more complicated. Okay. So and also want to remind you, this is all predictive causality, okay, not structural causality. All right, thanks for watching. I hope you learned how to actually implement conditional causality test among 3 time series. Thank you.